Hello, welcome to another stream. Welcome. So today is, what's day today? I don't remember. Today is Wednesday, and that means today, according to the schedule, we are programming in C++, and we continue to develop our text to video renderer. That's what we continue to develop, which is called Vodus. So hello everyone. Hello Iguduk, hello Copycasted, hello Out9, hello Mr. Botka, hello Jun Free Foo, apparently Potatoes, Copycasted, Ivan Ho, hello, welcome. Really glad to see you all today. So, yeah. The usual Wednesday C++ stream, the usual Wednesday Vodus stream. So let me see what we have planned for today. Maybe we can also take a look at what Vodus is, but I'm pretty sure, like right now, we have people who all know what is Vodus, right? It's this, simple thing that just takes your chat log and turns it into a video, which is quite awesome, not gonna lie, but it's not really finished. And I don't really know when it's going to be finished, because there's a lot of things needs to be done. So let's actually fetch the latest stuff. It's our chat log, yes. And take a look at the current state of this entire thing. Alright, merge origin master. There we go. And nice change, by the way. I don't even know what exactly I did in that change. It's quite sus, not gonna lie. Yeah, I agree with you. Alright, so Twitch module, remove redundant login from, oh, okay, so I literally removed a single line. So let me see if I can remove this branch, redundant login, yeah, classic. And let's rebuild everything. 2-2. Cheers. God damn it. Spilled over myself yet again. Interesting. Takes quite a significant amount of time. But maybe it's just warming up. Do you change your builds regularly? Like every week. Yes. Ring from the same. Yeah, no. Roughly every week I just buy a new bottle. Yeah. I should probably buy a proper water bottle at some point. I'm just too lazy. So we have a sampled chat log. This looks that looks like this. So you see it's a regular chat log with people spamming emotes and stuff like that, and we can turn it into a video like this. It's not going to be the official way of calling this program. Obviously, it's just test way, but essentially it's a batch program that processes your chat log. That's what it does. Then we can take a look at the video itself, and this is how the video looks like. So that was generated from the text file that I showed before. Yep, and it works quite great. And we also started to support Twitch emotes, which is quite cool. But I don't remember if we support global Twitch emotes. Also supporting Twitch emotes is kind of complicated, because there are different emote packs, right? And some emote packs are available for some people, some of them are not available for some people. So that turns into a very complicated system where we had to analyze your chat log first, and maybe query Twitch API a little bit, just to figure out who has available emotes and stuff like that. So yeah, I don't know how we're gonna handle that. But yeah. It gets very complicated very quick. Why not stream the video instead of waiting for it to generate the whole thing? What do you mean stream the video? You mean preview as well? Is that what you mean? So also preview while you're rendering, is that what you mean? Don't quite understand. Or you mean, you probably think that maybe it's, yeah. This tool is not for real-time processing. That's the thing about it. It's not for real time. So I would really recommend you to check out the source code. There's a video with explanation what this tool is all about. And the idea is that you have a VOD right, of already like a past stream. So this is a past stream. But you forgot to record your stream with a chat overlay, right? So, and you want to add that chat in post-production. So the only thing you have is a chat log and a text file. So what you do, you would take that chat log, turn it into a video and add it to your VOD in a post-production. For this kind of scenario, you don't really need preview, even though we do have a preview. Right, so we can actually do it like that. So for the scenario this application is designed for, you don't need that, but we still kind of can do that. Output type, I think preview. Yeah, there we go. So there we go. It basically, you know, renders and automatically previews it as well. So this is basically what you asked for, right? This is you asked for this. And there you go, we can do that. But even though we can do that, the tool is not really designed for that anyway. So yeah, you would run this tool maybe on some sort of like a rendering server from time to time. Maybe it's going to be called in a script. When like a streamer releases new VOD, you want to download their chat logs and then process them, turn them into a video or something like that. It's not like a self-sufficient tool, right? It's just a tool in your tool set for, you know, post-processing the VODs. Post-processing the VODs. Cheers. All right. So what do we have planned for today? Have you researched how people do this already? They write some dumb Python script that generate a sequence of PNGs and then they use a FFmpeg to compose that into a video, which is fucking lame in 2020 in my opinion. Alright, so we need a tool that is written in a proper programming language that generates a video like directly. Like, Jesus Christ, like fucking sequence of PNGs that you turn into, like, come on. Because I know why they do that, because it's the obvious and easiest solution, and I used to do that as well, but it's not the solution for 2020, like, what the fuck is this shit? Alright, so here's an interesting idea. Right now we're producing some sort of like a raw files. I call it mpeg, but it's actually... where is the output? It's not really mpeg, I think. Output mpeg. Yeah, mpeg sequence. So it's like basically just a, you know, sequence encoded with a codec, right? But without any particular container, right? So, and like we don't support MP4 or MOV or AVI or anything like that. We don't support this kind of containers, and I think it's kind of lame. It's similar to RAW or PCM. Okay, I see. That's what I'm talking about. That's what I'm talking about. Is it? Ah, okay. Well, I don't know. Basically what I do, I just receive the data from the codec and I dump it into the file system. And that was in the example that came from FFmpeg, and that worked. And in example, they call this file mpeg for some reason. So we can actually Google up what is mpeg sequence. I'm kind of curious. So I don't really know much about this kind of stuff. Let me see. What the fuck is this language? I need English. Moving picture expert is Alice working. Compression could you graphics data and transmission. File formats. Alright. Okay, so what I actually use here. So if I go and find one of the codecs, right? If it opens up, of course, because Emacs codec. Yep. Oh, that's kind of interesting. I see how we support. Okay, so we do support MPEG 1, but the way we do that is basically, if the codec is MPEG-1, we are writing that container ourselves. Apparently, it's so simple. It just contains the, you know, some sort of like a magic number. You put that into a file, and yeah, that's it. I guess that's it. So that's why it works. But we don't support like a proper container format. And as far as I know, it is done with a separate library from FFmpeg, which is called libav format. Right. So encoding is done with libav codec, libav codec, right? And the actual like containers and stuff like that are done with libav format. So so today we need to start with just exploring this library and see what it's all about. So yeah. Let's see. Maybe we will be able to finally generate like MP4 or AV files and stuff like that. Hello, 4air. Welcome to the stream. Okay. So libav format library provides a generic framework for multiplexing and demultiplexing, mixing, demuxing, audio, video, and subtitle streams. It encompasses multiple mixers and demuxers for multimedia container formats. Okay, so this is the part that we care about. It also supports several input-output protocol to access the media sources. Okay. Is there any examples or documentation for this thing? Okay, so if I click documentation, will it give me? It doesn't seem to be giving me libav format. Okay. And when I click here, it goes basically back. Interesting. So, okay, so they have some sort of a source code. We'll probably have to go to the source code. Maybe in the source code itself there is something. So is there like a GitHub? All right, so this is where it is. Libav format. Okay, so it has a separate folder, and in that separate folder, maybe we have some sort of examples. We have some tests. But I'm not sure if tests are usually are actually useful for us. Okay. Oh, by the way, I just realized that I have a copy of the source code on my machine because I build FFmpeg from scratch. Right. So that means I do have libav format and stuff like that. So if I take a look at the tests, right here are the tests. RTMPDH. Okay. But I would like to have some sort of example. Oh, test random shared secret. Huh. Shared secret. Yeah, exactly. I would like to have like just a simple example on how to like produce a container file or something, but I didn't see anything useful. Libav format example. Can you floor the chat? Yes, I can. All right, so we found something here, and okay, so we can go through that. That's a lot of shit, not gonna lie. That's a shit ton of shit. Oh shit, that's shit ton of shit. Okay. So this is the entry point. It's kind of scary, not gonna lie. It's kind of scary. And the version is actually kind of weird here, right? So I'm definitely not using that version. I'm using 4.3 and this is 0.6, right? So we use 4.3 and this is 0.6. Can I just take this entire URL? Hello, Cozy White Bear, welcome to the stream. Welcome, welcome. And just replace it, replace 4 with 3. And is this a valid URL with an example? Nope. Fuck me. Thank you so much. And it's not even possible to find any, like everything is forbidden. Okay, it's kind of sad, not gonna lie. It's kind of sad. There's examples demuxing. There's also output example. To be fair, maybe we can find that file inside of the source code. Maybe we can find it somewhere here. So something like find type output. Was it with a dash? Was it with a dash? I think it was with a dash. So this is a demuxing. And what is this file? Output example. Yeah. So output example.c. It's a file type, name, and it doesn't exist there anymore. So maybe that's what we need here. The web computer is hosted from a Bulgarian provider. Cool, thank you. That's a very important information for me. Like, there's not much documentation about this thing, and it's actually kind of sad. Alright, how can it be used without using other libav? Virtually any audio file. Okay. This is surprising. I'm so confused. There's so little information on how to use this thing. Like, or any sort of explanation on how to use this thing. Decode audio file. So what is that? LV5, what is that? Is this an explanation? Okay. Because most people just use FFmpeg binary for their tasks. It's kind of sad, to be fair. Let's just go through maybe this example. Is that a good example? Maybe it will give us something. So AV initialize all muxes, demuxes in protocol for libav format. Does nothing if called twice during the... Okay, cool. V format context. Maybe I'm the one who's weird here, right? So it's kind of strange that we have to call one program for another program in 2020 just to get something done. It's like literally 1970 approach. Seriously. This approach was like invented in 1970, and is that what we're still doing? Seriously, to this day? Can we come up with something better than that to get shit done? Alright. Okay, let's just give it a try then. I don't know. So, libav format prob .cpp. I'm gonna use a CPP. Alright, and of course I'm gonna include my trusty aids, HPP. If you don't know what is aids, by the way, you can always check out here. Right, so it's my replacement for STD. Using namespace aids, and there we go. So this is the entry point and stuff like that. So maybe I also wanna, you know what? I'm gonna put this thing inside of SRC, right, along with the whole source code. So, and this is where we're gonna keep all of that. So maybe on top of that, I want to call it with underscore. I'm gonna call it with underscore, and we're gonna add that to the build. Libav format prob depends on SRC. Libav format prob CPP, and probably also on aids as well. Right, so it depends on these two things. And so what do we need here? We need to call compiler, and we also need some flags. So I think I'm gonna just use the same flags and libs as the vodus, because that kind of makes sense, because it's pretty much what we're gonna use it, where we're gonna use it. And also vodus lib. Is it vodus libs? I think it was vodus libs. Alright, so now I should be able to just build this thing and see how it goes. It's going to make minus b, blah blah blah. And it does not even compile because we haven't defined main. What the fuck is going on? In function starts undefined reference main. Really? This is where it is. Did I really fuck it up that badly? Let me actually do a make Oh yeah, because I have to do it CPP. I'm sorry, I'm sorry. Shit. Oh shit. Oh fuck. Okay. Am I that dumb? Am I that dumb? Wait a second. Yes, I am. I am that dumb. Jesus Christ, I'm really, really sorry. What the fuck? Like, it's just... I have a huge brain fart right now. Oh my god. Okay, so I managed to create the executable that does nothing. That was hard. That was fucking hard. Okay. So let's start with this thing. From every other language I call the FFM binary from the host language and process communicate with. Oh my god. Jesus Christ. Is that the way to go in 2020? Seriously? Am I doing it incorrectly? Am I doing it incorrectly? Because... Okay. Alright. So... So we have to first do... I had to pipe between go and exec command in other languages. Okay. So this is the first thing we do. This is the first thing we do. And does it even compile? It does not compile because we need to include all of this stuff, right? So that's what we need to include here. So I think I'm gonna even do it like that. And does it even work? Void register is deprecated. Nice. So this example is very old. And their deprecation message doesn't even explain what you have to use instead, right? So they just basically said deprecated. Initialize, yeah, classic deprecation. Nice. Thank you so much. Thank you. All right. Cool. librav codec librav format sample code. All right. So that's actually very fucking bad. How am I supposed to create like a robust application if I have to like have a separate executable? What the fuck is this shit? I do not accept that. I do not accept that. Seek srtmp URL. And none of these examples actually make any fucking sense. Like, why the fuck is URL? Like, what URL has anything to do with that? Absolute URL? Is this like a URL parsing library? Is that what it is? What the hell are those? What the hell are those tests? What the fuck is this shit? Oh my god. I'm so fucking sad at the state of this library. Jesus fucking Christ. Am I using the right library? I'm using the right library. Okay, so alright, so that means we're not gonna do that today because apparently it's a huge rabbit hole not worth streaming. No, fuck that rabbit hole. I'm gonna do that off screen. Seriously, like it's not for the stream. This kind of shit is not for the stream. You can use a FFmpeg for input stream. Have you heard what I said before? Do you even listen to what I'm saying? You obviously don't. Alright, so let's start working on something else. Uh, so yes, support for Unicode emojis. So this is what we need here. Support for Unicode emojis. So to support Unicode emojis, we need to find some emoji pack that is like free to use. So let's actually Google it up. I'm so disappointed at the state of FFmpeg. This is fucking embarrassing. Like, Jesus fucking Christ. The API is so convoluted that it's easier to just use a binary. I don't know if they intentionally did that or they're just bad at designing APIs. So if they intentionally did that to like for some sort of like job security, this is fucking evil. This is straight up fucking evil. Yes, it does support Cyrillic. Free emoji pack. This is how a typical C library looks like. You haven't seen a lot of C libraries apparently. They're the ones that Discord uses. And Twitch. Okay. Twitter emoji pack. Twimoji. Completely free, yes, you read. Okay, whatever. Download. Grab all emojis as vector artwork and use them for any commercial personal project. Okay. So, do I have to sign up somewhere? Hopefully I don't have to. So it's on GitHub. Nice. It's on GitHub. Alright, so... Assets. Is it in assets? Yes, it's in SVGs 72 by 72. Oh, fuck me. Why is it so slow? Oh, shit. Oh my god. Yeah. Okay. So where are we gonna put all of that? I need some place. Okay, we have assets here, so might as well actually put them here. It's gonna take some time apparently. I don't know how much time it's gonna take. While it's downloading, might as well actually find more information about libav format. I wonder if I so while it's downloading FFmpeg libav format, so we'll do a grep. Also this kind of thing, mp4. Do they have anything? MP4 description. This is actually kind of interesting. So, all right. So, parse MP2. Where do they use? Can we just remove these O files? What is a D file? So, and let's find where they mention this kind of thing. They mention it in here. Parse MP2 descriptor. All right, so where else? MP4. That's actually very interesting. So parse MP4. You need to apparently encode data in a VPAC. It's free food. I know you're talking about libav encode and shit. I know all of that. Jesus Christ, dude, this is literally what I do already, otherwise this program wouldn't fucking work. Oh my god. Alright, whatever. I'm sorry, I'm really tilted right now. Don't tell me to relax. Go relax yourself. This is the kind of shit I have to deal with every day. Alright, so what do we have? Emotes. So this is actually like this kind of library. These are the assets. So I suppose the names, yeah, so they basically they represent the code point, right? This is a code point. Yep. I think maybe we can even use all of that. But these are SVGs. So the most we need are these ones. This, yeah. Which is kind of interesting. Oh, this shit. This is actually pretty fucking big. Oh, this is because these are ligatures. Yeah. So this is ligatures because you achieve them through the ligatures and stuff like that. This is very interesting. So that means at some point we'll have to support those ligatures. Yeah. Oh shit. Okay. And I was thinking if we can reuse the already existing emote mechanism, but I don't think we can, because the existing emote mechanism actually uses words. So essentially it maps a word to a path on a file system, right? So, and we cannot do it like that because like emoji may not necessarily be a word, right? So we need to have like a slightly different mechanism and whatnot. Interesting. How can we easily build a map? How can we easily build a map out of that? By the way, I need to save the link to the Twitter emoji. Thank you everyone who suggested that. So we're gonna keep all of that. I'm not quite sure. Do we have credits? Yeah, credits. ORG. The fuck is this shit? What did I do? Wait, what? Did I accidentally copied something? I think I'm going crazy right now. What the fuck is going on? So what I'm thinking is that I need to build like a test application where I can feed like a bunch of emojis into, and it will try to look them up in the file system. Yeah. So I think it's going to be a pretty good idea. So let's remove this shit. Yes. Let's remove that. Emoji lookup is going to be src emoji lookup cpp. And just that. I don't think we're going to depend on anything, actually. So that's why I don't really need C flags and libs. But I still kind of want to... Okay, so let's use Vodus C flags, because I still need W all and other good flags. So I don't mind linking with a bunch of garbage because it's going to be temporary anyway, because I'm just doing experimental code. To be fair, like, why do I need a separate executable if it's an experimental code where I can just go to the Vodus itself? I can just go to the Vodus itself and create a separate entry point. So, yep. Thank you, Lord Alpaca 666.
PHP Life.
For 100 bits, thank you so much. Alright, so we need some sort of a function where I could feed the code point. Actually, maybe even several code points, because you can have like ligatures. They're not ligatures. What are they called in the context of Unicode, right? So they're called some sort of other fancy name. To be fair, I don't care. But yeah. So, and we need some sort of like this. Look up emoji. And I'm gonna provide like a uint32 like code. And we're probably gonna have like a base path. So here's the base path. Graphems, yeah, because you need to like have a separate word for that for some reason. I don't understand why. Alright, whatever. Anyways, so it's gonna be something like assets. So we're gonna actually go here somewhere. So they always remove the leading zeros. That's what's interesting about it. They always remove the leading zeros. That makes sense, I think. I think that makes sense. Yeah. Now, we need to compose the URL. Right, we need to compose the URL. How are we going to do that? I think in aids somewhere I have a dynamic array. And this is what I can use here. So it uses reallocate, and I can even, yeah, that's cool. So I can do dynamic array char. So this is going to be path. I add base path. Then I would like to render that thing into. Yeah, okay. Let's have some sort of a buffer. It's going to be buffer. Let's say 20, whatever, and we're gonna use sprintf into that buffer, sendprintf actually. Size of buffer. So it's gonna be x, and we might as well actually put png there, but yeah. Well, concat doesn't work. Okay, so that also has to be. I have to be very careful. strlen. Right. And this is gonna be png. And does a sendprintf actually return anything? I don't remember what it returns. It does return something, so I can use that as the length, like this, buffer n. So that should work. And then I also want to push like something like this to make it a null terminator. Okay, cool. So this could be actually a little bit bigger just in case, I don't know, I have a little bit of paranoia. Afterwards, we need to check if this file exists. Right, we need to check if this file exists. I forgot how to check that, but I think we had something like that in the emote downloader. Exists. Path exists. Okay, so we do have that. Path exists. So essentially you just use stat. So this is going to be stat, of course, to do not cross-platform. And we have a path name. This is a path data, right? And if path exists, we probably have to return it somehow. But that also means that you have to delete it yourself. Yeah, this is going to be something like this. Return path data. Otherwise, return nothing and free path data. Okay, cool. So now we should be able to look up different emojis. This is not what I wanted to do actually. Sorry, chat. I'm really sorry. Expected unsigned int. Okay, yes, that's true. So can I just do something like code? So it's probably gonna complain that okay, stat buff requires including unistd and stuff like that. Alright, so this is what it requires. I don't remember how much of that I need to include there. I'm gonna include it somewhere like here because it's a temporary code anyway, so I'm just testing how this entirety is gonna work. I'm just testing it out, nothing special. How many hours a week does a CS student study? 69. 69 hours. Okay, so why am I building release? Okay, cool. All right. So it seems to be working. Now, here's an interesting thing. In AIDS, we have a pretty cool function. UTF-8 get code. So essentially, you provide a view, and it will return you the code point of a Unicode character that it sees, and it also will give you the size of that character. So this is the function that we can use for all this stuff. So essentially, let's take a look. Let's actually take some emoji, like a joy crying emoji, right? I'm gonna copy paste it, and I'm gonna just copy paste it right into the source code. So something like we're gonna have something like string view input. So this is the input, right? And if you try to do code UTF-8 get code input, and also you have to provide the size, but I don't remember if you have to provide the size. Yeah, you have to. There's no option to not provide the size, which is kind of dumb in my opinion. I think I should have actually provided an option to not provide the size, right, if you want to ignore it, but it adds additional branching, right? So we already have a lot of branching here, but maybe, I don't know. So you need to provide the size. All right, so it's going to be 0, it's going to be size. And this is where we're going to have the code, right? So here's the code. And we can even try to print that code, right? So if we print it like this, to the code is this, Alright, let's try to compound that. So this thing has to be SV. Alright. Oh, and this thing can also be maybe in case if it's not a valid one. So I can do something like unwrap or panic. Incorrect UTF-8 character encountered. Incorrect UTF-8 character encountered. Alright. So cool. So let's see how it's gonna go. Let's see how it's gonna go. I'm gonna just try to run Vodus debug if I can reach it. And the code of this thing is that. Alright, so now what we can do, we can try to look up that code. We can try to look up. And by the way, I just realized that I could have actually wrapped all of that in maybe. I don't know. But maybe, like for this case, it just doesn't really matter. I'll just keep it like that. So look up emoji. Maybe it's 8. Yes, it's from 8. It's from 8. Code. So in here we're gonna have a path, right? If path equal null, right? If it's equal null, we're gonna say something like print ln std out could not find any emoji with the code, and we're gonna provide the code here as an indication of that. Otherwise, all right. Emote is located in, and we're gonna provide the path. There we go. So this is how we're gonna go about it. You found it. I actually found it. It's pretty cool. Yep. So we know how to look that stuff up. It's pretty cool. I'm not gonna lie. So let me see. Let's try something else. Let's try this DVD thingy, if I can copy paste it. For some reason it's kind of hard for me to select it. Is it actually 2 of them, or I don't know. Are these things with graphems? I don't understand. Alright, so I'm gonna try to copy paste. So this is a space, I don't need that. What if I put it here? It's a single thing. Okay. So we can try to actually iterate through all of these things. Yeah, so the idea is going to be the following. While input is not empty, right? While it's not empty, we're going to keep getting this stuff, right? And looking up the path, right? But it's going to be slightly different, I think. So it's going to be println std out, and we need to print the emoji itself. So how can we print the emoji itself? Well, we know the size of it, right? So you know that UTF-8 is actually multi-byte format. So what this function does, it returns you not only the code, but the size of that character, UTF-8 character, in bytes. So you can do like a substring of it and extract it and actually print it, and it's going to work. So that's pretty much the idea of all of that. So and essentially, if you want to print it, you have to do input subview 0 size, and that gives you that, you know, that UTF-8 character. So I think this is how subview works, but I'm not 100% sure. Yeah, I think this is how it works. It's a start and count, and yeah, that's exactly what we want. And after that, I want to sort of put some sort of a separator, right? So here's the separator. Then we're looking up the emojis, and we are going to print just the path, right? So I think we shouldn't print a new line here. You need some kind of script and emoji segmentation where are some Unicode code points properties that tell when. Thank you. Thank you. All right. Not found. Okay, so after that, we need to actually move forward, right? So I think we have a special function for that. It's going to be input drop size. So essentially drop this amount of what's that hanging on the clothes rack? I don't know what you're talking about. I'm sorry. Is it maybe chop size? Okay, and after that, let's actually run it. So there you go. So as you can see, it actually iterated through all of the Unicode characters in the string, and for each of them, it found something. So if we take a look at this one, it's a CD. It's a golden CD. So that's pretty cool. That's pretty cool. We can also input some things here, like this, other Unicode characters. Hello, it's me. Who am I again? Hello, streamer. Okay, so let me run this thing, and as you can see, for those, for non-existing things, we say not found. Okay, cool. Now, I need to add support for Unicode graphems. The question is how we're going to add such support. It's a good question. I'm glad you asked. Unicode graphems. Let's actually read about them. Yes. So I don't see any useful information, to be fair. Unicode emoji graphems. How am I supposed to read them? Working with the Unicode and grapheme clusters. Okay. Is the chat being rendered epically today? It's okay. I mean, it looks the same as it looked before, right? So it's pretty epic, I would say. Like, we don't have much artifacts, you know, with the GIFs and stuff. So I'll see how it goes. So let's see, I never worked with grapheme clusters. So what I need to understand is how to detect that it's a grapheme cluster and like how to parse it. Yeah, at least the rendering part works, yes. Get a little bit triggered by FFmpeg yet again. FFmpeg is absolutely fucking horrible library. Jesus Christ. Okay. Finding the length of the string. Okay, I'm gonna read that a little bit later. Grapheme cluster. Grapheme cluster. Okay, so that looks interesting. Horrible font, Jesus Christ. Hmm. Okay, grapheme cluster is one of more Unicode points that should be treated as a single unit, but where processes text editing software should generally allow placement of curses. Okay. Actually, the concept isn't that new Unicode formalize. Okay, how do you detect them? Oh. Actually, useful information is behind the paywall. Of course. Fucking, of course. Alright. Clusters. Another yet high level abstraction of characters is that the grapheme cluster. Okay, how do you determine the beginning and end of it? All combining character sequences are graphemes, but there are other sequences of const points that are as well, for example, as one. For certain classes of applications such word processors, it can be important to operate at the grapheme level rather than at component. Wait a second. Are these sequences of characters basically hard-coded in the specifications and don't have any rules on how they're combined? Are they? So, do I understand that correctly? So that like each individual grapheme is just basically like in the standard. Okay, Unicode list of all graphemes. I don't know. I thought maybe it's kind of similar to UTF-8. I thought it's similar to UTF-8 where there are rules on how long it is. Right. So so something like that. Graphemes. So if there is a list of like graphemes, of all graphemes, I need to keep it actually. Right, I need to keep it. Extract graphemes, you can process all spaces. Unicode characters name index. Oh my god, it's so slow. Nobody answered the question that I asked, by the way. Are they hard-coded in the specification? Are sequences of code points that are called graphemes hard-coded in the Unicode specification? This is actually a very simple question. It's a super simple question. It's a yes or no. And apparently, like, nobody can tell me. Like, how do you determine the graphemes? Like, does anybody know an answer to such a simple question? Are sequences of code points that are called graphemes hard-coded in the Unicode specification? Is there like a global list of them, or they're combined by specific rules? So, like, I just need the answer to that question, and that's it. I don't need any other information, seriously. Apparently, they aren't. Okay, so we're moving somewhere. Thank you, thank you. Finally, chat is being useful. Thank you so much, Desenor. That means they are not hard-coded. So I wish I could find some useful information, but Google is being an ass yet again. Graphemes, rules. Grapheme cluster boundaries. Wait a second. Okay, it's finally fucking useful information. Why is it so fucking hard to find anything like that? Oh my god. What the internet turned into. Absolutely impossible to find any useful information. It's important to recognize that what the user thinks of as a character, a basic unit of a writing system for language may not be just a single Unicode code point. Instead, the basic unit may be made up of multiple Unicode code points to avoid ambiguity with the... Thank you. Okay, let's just jump to something important. Grave accent is a thing of a character, yet actually represents... Okay, boundaries are important for collation, regular expression. Yeah, I know, that's why I'm here. As far as the user is concerned, the underlying representation text is not important, but it is important that editing can be treated by... Okay, this document... Okay, moreover, there's no... Okay. Apparently I have to read it. There's so much fucking useless information. Interactions, word boundaries, line boundaries, sentence boundaries should not occur within graphemes clusters. Okay. The underlying presentation text is not important, but okay, can be treated. Graphemes clusters can be used as unit by default for processes such as the formatting or drop caps. Okay, for example, okay, the document defines a default specification for grapheme clusters. They want to kill me. They literally want to kill my brain with this shit. For example, okay, simply editing. No, between graphemes clusters and keys on keyboard, a single key. Cool. Provide approximation of where to put cursor. The text editing, the text framework. Some constances. So graphemes cluster may also be used in searching and matching. For more information, see Unicode technical standard. Right, and regular expression. I'm not sure if I need them, but we'll see. The standard provides a default algorithm for determining grapheme cluster. But fucking finally, okay, where is it? Link, where is it? Give me the algorithm. With two variants, legacy grapheme, they even have a legacy system, of course, and extended grapheme. The most appropriate, like, just fucking remove all of that shit above, just fucking throw it in the trash, and give me just a link to where that algorithm described. Jesus fucking Christ. The most appropriate variant depends on the extended graphemes. This algorithm can be adapted to tailored grapheme. Okay. Simple grapheme clusters. Those people, I swear to God, those people, they just, I don't know. Collation algorithm, is that the thing that actually, you know, does the magic? Unicode collation algorithm. Introduction. Is a general term for processes and functions demanded a certain order of strings of characters. It is... Unicode regular expressions. Okay. Grapheme. A sequence of characters consider a unit in collation such as Slovak and collation grapheme. Welp, I guess I need to read all of that shit. I guess I have to read all of that shit to actually understand how to do that. This is kind of sad. This is very sad, but that's probably what I have to do. Is there any like more high-level overview of this Unicode collation algorithm? Because that's what we need. I don't even know what that word means. All of that just... Okay, so there's a Wikipedia page at least. Oh, I fucking hate this highlighting. Is the algorithm defined, okay, which is a customizable method to produce binary keys from strings. Represented in any writing system, you can be represented in these keys can be efficiently byte-to-byte compared in order to collate. I don't even know what is a collate. So let me, like, the problem is also the language barrier, like I don't understand this word. To arrange information that you have collected in a sensible order. Okay, so it's not the same as sort, right? Sort or order, collate is sort of okay. That starts to make sense. That starts to make sense. Okay. Oh, let's say 1 hour. I think 1 hour should be enough for you. Binary keys from strings. Right, in system language. I see. Collation algorithm. I have no choice but to read all of that shit. And I'm pretty sure there will be like less than 1% of useful information there. So what is collation, chat? Does anybody know what is a collation? It's a general term for the process and function of determining the sorting order of strings of characters. It is a key function in computer systems. Whenever a list of strings is presented to the user, they are likely to want it in a sorted order so they can easily and reliably find individual strings. This is such a relevant information to me. I love it. Thus, it is widely used in user interfaces. It is also crucial for databases, both in sorting records and in selecting sets of records with fields with a given bounds. Collation varies according to languages and cultures. German, French, Swedes sort the same character differently. It may also vary by specific applications, even within the same language. Dictionaries may sort differently than phone books and book indices. For non-alphabetic scripts, such as East Asian ideographs, collation can be either phonetic or based on the appearance of the character. Collation can also be customized according to user preferences, such as ignoring punctuation or not, putting uppercase before lowercase or vice versa, and so on. Linguistically correct searching needs to use the same mechanism, just as V and W traditionally sort as they were the same base letter in Swedish. A loose search should pick up words with either one of them. Collation implementations must deal with the complex linguistic conventions for ordering text in specific languages and provide for common customization based on the user preferences. Furthermore, algorithms that allow for good performance are crucial for any collation mechanism to be accepted in the marketplace. Thank you. That's exactly the information I want from this document. That's super cool. That's so useful. Show some example of cases where sort order. What does sort order have anything to do with graphemes? I want to determine the fucking boundary of a fucking grapheme. Why is it so difficult? Unicode boundary of grapheme. Like, it's such a simple request. Okay, you group them. Okay, text segmentation. Okay, why is it so fucking hard? Like, Jesus fucking Christ, it's such a simple thing. What the fuck? Okay, so Unicode text segmentation. Maybe that's what we need here. Like, I don't mind, like, sophisticated algorithms or sophisticated rules or anything like that. I don't mind that shit. But what I cannot tolerate is this kind of fucking obnoxious documentation that makes it difficult to understand. Right, so we already have a complexity, like, of how to deal with all of that, and on top of that we have this bullshit that you have to get through to get useful information. That's what I cannot tolerate, unfortunately. I wish I could, actually, but I cannot because I have a very short attention span. I'm really sorry. Rather than concentrate on algorithmically searching for text elements, often called as segments, a simpler and more useful computation instead detects the boundaries or breaks between those text elements. The determination Yeah, determination of those boundaries is often critical to performance. So it is important to be able to make such determination as quickly as possible. For general discussion of text elements, see chapter 2, general algorithm of Unicode. General structure of Unicode, I'm sorry. The default boundary determination mechanism specifies in this, like, okay. I don't want to even pretend that I like this shit. What the fuck? What the fuck? I found what I was looking for. Well, didn't I already read that? I think I already read that and I said, I went back. I'm literally going in circles. I've already been there. Like, I'm literally going in circles. Because this is from where I got into these documents and they actually, okay, well, I mean, I googled myself back. Alright, so that's kind of interesting. See also, where is my character? Display of grapheme clusters. Alright, cool. We're not gonna support them yet. So that's gonna be the conclusion for today. So we're gonna support only like these like one characters, and for actual graphemes we're gonna have a separate to do. And I think maybe grapheme handling should be actually part of aids, as you know, yeah. So at some point I'm gonna add it to aids. We'll see how it goes, because we have UTF-8 parsing, so I might as well actually then later add it there. So yep, that's how we're gonna go about that. So, and I think it's even better because, as I always say, that you don't have to implement everything at once. Let's implement something working somehow, because you don't, for majority of the emojis, you don't really need graphemes if you think about it. All right. So let me think how we're gonna look them up. So I would like to, yeah, on each character, when we're rendering each individual character, all right. So I think I want to make a small break. FFmpeg is shit. Unicode is shit. Oh my god. Today is a pretty bad day for me, at least. Today is a pretty bad day. But anyway. Yeah. So the problem is not a really sophisticated algorithm. The problem is their specification. Like, if specification was a little bit easier to, you know, read, or they would go straight to the point, I wouldn't mind implementing like relatively complex thing. But they just want you to be an ass. Alright, let's make a small break. You guys have fun. Alright, so welcome back. Now we need to probably save all of that to the memory and stuff like that, but I'm thinking how exactly we're gonna do that. I really want to reuse my emotes mechanism for storing the emojis. We'll see how it goes. So to reuse that, I need to essentially add them to. I need to add them to the mapping CSV. To add them to the mapping CSV. So I wonder what is going to be the easiest way to do that. I think I have an idea. We can just process this folder file by file, right? What is this? Oh, it's like copyright symbol. Is this the code of the copyright symbol? Really? It fits into like 1 byte? Is that what it is? But it's a... Yeah, it's probably that. Alright, here's an idea. Let's iterate through all of the files here. Let's iterate through all of the files. Let's iterate through all of the files. I wonder if we can do... Yeah, we probably can. And now... fucking Russian. Alright. So, how do I use derend? I think I already used it at some point. Derend. Alright, so I need to go to something, right? I need to go to something and find derend. Where? I forgot, it's load rooms, I think. I think it's load rooms. Nah. Open dir. Yeah, there it is. Yeah, this is the general algorithm how you read from the folder. So this is what we're going to use here, essentially. So we need to open the rooms directory, open dir, and something assets I already forgot. It was in the base dir. Oh yeah. So this is the base path. So I can just straight up use this base path. Base path. Alright, so it's not a rooms dir, it's actually a emoji dir. So that's what it is, it's actually emoji dir. It's gonna print a len. std error. Can't open asset folder. And this is what we're gonna go. So it's not, yeah, emoji folder. And we're gonna exit with 1. So after that, we have to start iterating through all this stuff. So we're gonna skip all of the folders here. Continue. And yeah, now we just need to parse the names and stuff. We'll see how we can do that. std out the name. Alright, cool. And afterwards we have to close this entire. I think I might as well actually defer close it. Defer close emoji there. I also want to do something like this. Yeah, I don't like continue. Cool. So let's see if this compiles and even works. Maybe it even does. Maybe it even does work. So you need to import durand h. Still doesn't compile because what? Close dir. Static typing, by the way. Static typing emoji. I'm just copy pasted some stuff. I should have not copy pasted, but I mean, it is what it is. Alright, so if I try to call this thing, cannot open. Yeah, you cannot. I wonder why. I wonder why. Did they make a mistake in the logic? Yes, I did make a mistake in the logic. It has to be null. So that makes sense. That really makes sense. Is it gonna work now? Come on, compile a little bit faster. Thank you. And it couldn't find anything. I'm so fucking happy. I wonder what the fuck happened. I wonder what the fuck happened. All right. So what the fuck? Ah. Again, I actually inverted all of the logic here. Actually inverted all of the logic. Okay. Alright, so here are all the files, and essentially one of the things we can do here is go through their names and parse those names. Sometimes it even prints like a space. Oh, this is because I'm using tmux. Alright. So yeah, we can turn these names into like UTF-8 strings. This is one of the ideas I have. And then, once they are turned into UTF-8 strings, we should be able to shove them into the emote cache and use as a regular emote in the system. So that's actually pretty cool. But the limitation is going to be is that emotes has to be surrounded with spaces, but it's going to be temporary limitation. So we'll see how it goes. So we need some sort of a function that will accept the path, emoji path as UTF-8 string, right? And we'll see how can we even do that. So I suppose the path is going to be just this, and where are we going to save it as UTF-8 string? So we'll need some sort of a buffer where you want to save it as UTF-8 string. We can probably just return it somehow. So this is not particularly useful function anyway, so I might as well remove it. So this stuff is not needed anymore. Yeah. Yeah, we can remove it somewhere here, like this. Okay. So essentially, this is the name, then UTF-8 str, emoji path as UTF-8 str is going to be d name. There we go. And we're gonna do the following thing. We're gonna also print that just to see what's going on here. If that work. Okay. So how we're gonna parse all of that? It should be pretty straightforward if you ask me. So maybe we're gonna even accept path as a string view. Yeah, we're gonna accept it as a string view. Yeah. While path What's up, Chromosome Drift? Welcome to the stream. How are you doing? And path not equal to .png. This is actually quite important. We're going to do the following thing. It's not going to be that easy to perform, but we'll see. We'll see. So path chop by delimiter. And what's going to be the delimiter? The delimiter is going to be just this thing. Oh yeah, I think it's not particularly great. So what we can do here is path chop by delimiter, and we're going to chop it by dot, right? And we can turn it into an input. So here's an input. And we also want to assert a quite important thing, that path is currently equal to PNG, right? So SV PNG, there we go. So in here, we're starting the actual parsing of this stuff. We're starting the actual parsing. While input count greater than 0, we're going to chop by delimiter dash, right? And here we have unparsed code, which is interesting. Maybe we can instantly parse it as a number. I think we had something like that in AIDS. Chromosome Drift, thank you so much for Twitch Prime subscription. Apparently this is your first subscription. Thank you, and welcome to our epic emoji club. That's right, that's what we do here. Welcome to the epic emoji club. First step to any Twitch streamer. Yeah, thank you. I'm really flattered to be the first. Thank you so much. All right, so struct string. So I remember it had something related to hex. Hex. From hex, yes. You essentially can just use from hex, right? So you chop by this delimiter, then you do from hex, and you can turn it into any sort of thing you want. It could be uint8, uint32 actually, right? And this thing may return maybe. So we want to do something like unwrap or panic, right? Unwrap or panic. So, I don't know, incorrect hex number encountered, incorrect number encountered, and this is going to be uint32tx. All right. But it would be also nice to tell exactly what's incorrect. So maybe that's why I want to save that, like unparsed number. Hello, Toast TV, welcome to the stream. Welcome. So it's going to be unparsed number. Input chop by delimiter is going to be this. Yep. And that will give me an opportunity to do the following thing. How can I train my brain to think more like a programmer? What is a programmer though? So who is a programmer? Like, what's the criteria? I don't know. Unparsed. A programmer is someone who writes software. Interesting. Maybe you just have to write software then. If a programmer is somebody who writes software, so to think as a programmer by the definition, maybe you should start writing software, and that will train your brain to think like a programmer. Somebody who at least masters one programming language and can write anything from scratch. Well, there you go. You answered your question. Master one language and write something from scratch. and you will start thinking as a programmer. So you ask the question, and you answer to your own question. So yeah, it is what it is. It just depends on the definition, right? So what is who is a programmer? We don't really know who is a programmer. Oh yeah. Markodef, hello Markodef, welcome to the stream. All right. Like I'm studying informatics and I'm in the 3rd semester. I'm noob at programming. Are you German, by the way? Println. So this is the X, right? So this is just a code point, but this is just a single code point. We need an algorithm to turn that code point into UTF-8, back into UTF-8. That's very interesting. So maybe this is something that we'll have to also implement for AIDS. Yeah, that sounds like an interesting idea. So in AIDS I have a function, right, that does UTF-8 stuff, get code, right? And maybe I want to have a similar function that actually does the opposite. All right. So because then I can use it to, you know, fill stuff up. So an UTF-8 can go up to 4 characters, so we might as well actually always return like 4 bytes anyway. So should be pretty straightforward. Should be pretty straightforward. No. So I might as well actually try to print all of them. So it's going to be something like print std out, and then we can do println here for this particular thing. All right. So let's see if it's gonna work now. So we're slowly parsing these things. Parsed and parsed x. So and also we have to turn it into a string. I don't quite remember. Register as a string view. Sister as string view. I'm not really sure if the electronics games are really good, that good at teaching programming, to be fair, because not all of them are connected to programming directly, except Shenzhen.io, I suppose. Man, I don't know. Because you know, the huge part of programming is actually not writing code, but dealing with this shit. So, is there a game that actually teaches you how to deal with this shit? I don't know. So. Yeah. Yeah, I know this game, by the way. I know this game good. Okay. So let me see if I manage to parse everything. Should be able to parse everything. Okay, so here are, so I extracted these numbers from, yeah. So they were hexadecimal, and I extracted these numbers from the names and I turned them into decimal numbers. So the next step is going to be for me actually, you know, turning them back into UTF-8 and stuff like that. So that's going to be the next step, and I wonder how we can even do that. So the easiest way would be to implement that is to implement an opposite operation to UTF get code. Something how to do with that shit for but contain programming thinking and culture. Yeah, I know, I pledge engineer. Code as UTF-8 to UTF-8. So, and what we're gonna accept here, we're gonna accept the code. We're gonna accept the code, and the question is how what we're gonna return there. I don't know. So it could be some sort of a structure. I forgot what byte mask would do in programming. Depending on how you apply it, it will do different things. So, yeah, it just depends on how you apply it. So I need some sort of a structure that maybe will just contain, you know, character. So we have buffers actually, string buffer. Yeah, so it's gonna be uint 8 bytes. It's gonna be like up to 4 bytes, and then we're gonna have some sort of a count, and this is something that we can return here, right? So I remember I already did something like this. And I think I actually did that in Tsoding. Yeah, maybe I can steal some code from there. I'm not quite sure. No, I didn't actually implement the opposite operation. Yeah, I didn't. I did not. Okay, cool. So, does anybody have any ideas on how to call this structure? Maybe UTF-8 char. This is how we're gonna call it. It's a UTF-8 char. So the only reason I wanna have this kind of structure is that because I don't want to manage memories. So it's just gonna be a single structure, and I can just return it and then work with it. Is this going to be edit to 8? Probably. I think it might be edit to 8, but I'm not sure 100% about that. Alright, so speaking of UTF-8, so I suppose we're gonna just have several ranges, but I don't know the exact ranges though, right? I guess I could calculate them, but maybe there is already like well-known ranges. Yeah, first code point, last code point. We can use this as the ranges, I suppose, right? So if you code point like between these, you'll have to have like 1 byte. If it's between this is like exactly here, it's going to be have 2 bytes, and so on and so forth, essentially. So let's go ahead and do that. So it's going to be if 0 0 0 code, and this is the last one. Imagine taking seriously suggesting rewrite something in Rust on the Tsoding channel. Only new people do that who don't watch my streams. Alright, New friends, am I right? So, so this is 1 byte, this is the second byte. 2 bytes. So this is the another one. So this is gonna be 3 bytes. And I wonder if it's gonna even work at all. Probably not gonna work. But you were writing some Rust, you synced. No, I didn't. You made it up. You made it up. Alright, so another one is gonna be else if. So this is another range. You made a deb. I made it? Did I invent it or something? Is that what you mean? I didn't invent deb. I'm not that smart. How is that correlated? I don't know. But yeah. 4 bytes. There we go. And here, I suppose we have like an assertion, right? If you go here at some point, that means, well, you're doing a wacky, oopsie doopsie, like, because we don't support that. Do we have panic? Oh shit, we do have panic. Yes, you can just do panic. Your code point is too big. Yeah. The code point is too big. This is going to be the panic. You have such a big code point. Ooh, I'm sorry. All right. What are you doing? What the fuck? All right. Now we need to prepare the results. I think the first check in all should be greater what? Do you have anything, any arguments? Like what? Well, Tsoding brain degraded from reading the Unicode specification. Yeah, it definitely damaged my brain. Like when I tried to read it, like for a couple of paragraphs, it's just fucking unbearable. It's kind of funny. Like libav format has almost no documentation whatsoever. Unicode has shit ton of specifications, but all of them damage your brain. Alright, so let's do the following thing. ETF8, char, results, and this time I think I'm gonna do it like that. So, bytes, and I can literally just use code here that I can convert to uint8. And I wonder if the rest are gonna be automatically filled with 0, but I'm not gonna try to guess it. I'm gonna just do it like that, and the count is gonna be like this. Oh, this is C++. You're not allowed to do this kind of shit in C++, at least in, you know, well, at least in the 70s standard, right? You're not allowed to do that. Okay, cool. So it's actually like implementing that is a little bit easier than implementing that, I think, because you don't have to like do these weird things. You just, well, you still have to split stuff, and yeah, we'll see. All right, so next one. No, it couldn't be, because it's unsized. It could be below 0. So yeah. So I need a mask that will give me that. So the easiest way to generate all of that is to actually have 1, right? You have 1, and then you shift like 1, 1, 2, 3, 4, 5. You shift to 5, right? And then you subtract 1, right? Who knows why the hell that will work? This is because we have 1, 1, 2, 3, 4, 5. You subtract 1 and you get 0, 1, 1, 1, 1. And this is how we got 5 ones. So this is the easiest way to generate all of that. Yep. And on top of that, we have to take this entire thing and shift it like, I would say 6 times as well. Yes, we have to shift it 6 times as well. Tsoding, shouldn't second in every shouldn't second in every be, or am I? No, it shouldn't. No. Yeah, like it's okay. So the left value is less than the right one. Okay. The left value is less than the right one. Okay, so usually I need to write something like if a less or equal x or less or equal b, where a is less or equal b. Right, we know that a is less or equal than b. So this is impossible to write in a standard C++. It's just no, you cannot do that, even though I want to, but no. So what I usually do, I sort of take x in here and split it with int. So this is just this, but with x split. This is how you're supposed to read that. Don't try to like understand it like logically something. No. Think of it as, you know, like a regular mathematical range check, right? So this is like a regular mathematical range check, but it's just syntactically adapted to C and C++ because it's a shitty language. Okay, so make sense? So, and now you can read these kind of things. So what I'm checking essentially is code point between these two values. Is code point between these two values. Is code point between these two values. It's very simple. It's actually, it's very simple. It's just a small syntactical adjustment for a shitty language. All right, so now once we're on the same page, let's continue. So I'm preparing a mask to extract this half of the number, right? That's what I'm preparing here. So, and I also need to shift the entire result like 6 times here, right? And that gives me a mask to extract this upper half. So after that, I can just apply that mask to the code point, and this is essentially like the axis of the first bytes. And now I need to merge them with like this thing, right? I need to merge them with this thing. So let me think how I can do that. It's a good question. So I might as well actually do something like this. So it's going to be const outer first byte. Let's say byte 0 mask, like this. So this is a byte 0 mask. And conversely, we can also have byte 1 mask, which is essentially this, but without this shift. So here are the masks. So I want to like sort of assign some names to this mask so I don't confuse myself. But I also need to construct this thing now, which is not particularly great. Alright, I can always do... Okay, I can always just generate 2 numbers here, right, like this. So it's gonna be 2, and then -1, right? So I can generate that. That generated me 2 ones, right? So because it generated this, and then we turn it into this. So the next step I can do, actually, I can shift it 5 6 times, right? So there we go. 6 times. So this is a mask, and this is a marker. We can call it something like auto byte 0 mark. It's called header. For some reason I want to call it a header. Yeah, so this is just a header. What the hell is Emacs? Could you please stop, you fucking Emacs? Jesus Christ. Alright. Seems good. Seems good. So this is the header. I can also do something like that. I'm gonna align it with equals. And can you Vim do that? So this is the header. It's actually not header 0. It's just like literally the header. And these things are, how would you call them? If you call this a header, what is this? Does anybody know what would you call it? Marker? Let's call it marker. Thank you, chat. Comes out a marker. Yeah, and I suppose marker is going to be like the same for everyone. 1, 2, 3, 4, 5, 6, 7. I don't know why I was counting that, but it's just this. It's literally this. All right, and essentially, right, you do byte 0. Byte 0 mask, and then you merge it with the header, and this is your first byte. This is your first byte, literally. This is, you see how easy it is? See how it is? You just bum bum bum, and there you go. Here's your first byte, and you can put it into the result. How about that? How about that? Isn't it epic? I think it's pretty fucking epic, my god. Alright, so yeah, this is literally your first byte. We might as well actually cast that shite to that byte. There we go. Are you happy? Are you happy with your first byte? It's kind of fucking exciting. Alright. So the second byte is gonna be as easy as the first byte. So essentially use byte 1 mask. But instead of a header, you're using marker. There we go. Are you winning, son? Yes. So, and this is like this. Then, oh, by the way, I forgot to tell that this is 1. Then this is actually 2. And there we go. Here's the result of 2 bytes. So this is how we, you know, parse this 2 byte situation. And of course I forgot to do something like this. There we go. What the fuck is going on, Emacs? What the fuck is this shit? Emacs, are you okay? Are you okay, Emacs? Probably not. So Emacs is definitely not okay. Okay. So this one is going to be a little bit more sophisticated, but what's fine is that I think marker is the same for everyone. So we can just put it here. So here's the marker. We don't have to worry about that. We don't have to worry about that. So this is that. But the... oh, and the byte 0 is going to be the same. Byte... yeah. Byte 1 is going to be the same, so we can also extract this thing here. So let's call it like extra byte, e byte. Okay, so yeah. So this one is a first byte. This is the first byte. And the extra byte. Okay. Alright. So I think that goes quite well. Alright. So I think I'm getting the gist of it. So this time the header is going to be slightly different. So const outer header. Right. Instead of like 2 of this thing, I have 3 of them. That means I have to put 3 here, but I'll have to move them only 1, 2, 3, 4, 5 times, right? So yeah, so I increase this part and decrease this part. So this is how it works. First byte mask is gonna be slightly different as well. Oh shit. Oh yeah. Oh fuck. Yeah, so my initial assumption was slightly incorrect, but yeah. We will have to also move these markers as well. Yeah, we also have to move this marker as well. This is something that I didn't think about. Not the markers though. Oh shit, okay. I see. I see. I think I even make a mistake somewhere here. God damn. Yeah. I made a mistake. I made a severe mistake. Alright, we need to scrap all of that. We need to scrap all of that. I'm an idiot, chat. I'm an idiot. So, I need more names to keep track of things. Otherwise, it's gonna be hard. Maybe I'm big as usual, but didn't you implement Eat Your Fate in AIDS? I implemented opposite operation. I could do this one. So, as an input, we get this, and we get code point. But now I do the opposite thing. I have a code point, and I need to implement that. So, no, I'm not gonna ban you. I already banned enough people today, so I ran out of my ban quota. Sorry about that. Okay, so pizza. I think I want to make a small break yet again, chat. Yeah, I think I want to make a small break. Small break. 2 minutes this time. 2 minutes, not 3. Alright, let's make a small break, and you guys have fun. Oh shit, I'm sorry. Thank you. Yeah. All right, so let's continue. Because if you extract this thing, you also have to bring it back. And this is something that I didn't consider. So, alright, so this is going to be the header. So, header, const outer header, 3, -1, right, and then we move this entire stuff to how many things? 6 then. Hello, Penkwang-an, I don't know how to pronounce your nickname. Hello. So this is the header, and this is essentially this. And 1, 2, 3, 4, 5. There we go. Is it 5? So 6 of them. Cool. So this is the header. It's cool. So then we want to have something like mask, and again, the mask that we're trying to receive here is this mask. I could just take a header and reverse it, but it's actually not byte, right? It's actually not byte. It's 32 bits, so which means it will affect other bits as well. So this is something that I don't want. So maybe because of that. Oh, wait a second. I might as well actually. Maybe I need to be a little bit more careful. So it's 32t. So, and how many symbols do we have here? We have 6 of them yet again. So this is going to be 1, 6. So this is a mask that extracts that value, but it has to extract it like around here. So that means you have to add 6 zeros here. So that means it has to be something like this. 1, 2, 3, 4, 5, 6, right? And this is something like this. Yeah. So that's what we're doing essentially. So this is this is what mask has to be. So you have 6, then you do -1, and then you shift it a couple of times, like 6, like this. Wait a second. Right. So I didn't make any mistake, didn't I? I think that's the right way of doing of making this mask. Right. That's the right way of making it. Yeah, I think it is. Because you move it 6 times, then -1, and then is this 6 times? Yes, it is 6 times. All right, looks cool to me. So if you want to extract the first byte, you do this kind of mask, and then you'll have to bring it back like also 6 times. Right, and that gives you that value that you can then easily merge with the header and get the first byte. And of course, after that, you should be able to convert it to int 8. I think this is the first. This is the first byte here. So this is the first. You should have 8 character. So this is the first one, and what's going to be the second one? Well, we need another mask. So this time, yeah. So this is extend. Right. So this is extend, and in an extend, what we want to have this thing. So this is the extend. And essentially extend is going to be what? It's just one moved to no, 1, 2, 3, 4, 5, 6, 7. Actually to 7. So that means, yeah, I already realized that I made a lot of mistakes in my original implementation, so yeah, it's kind of strange. So we have mask and extend. So this is the header. So this is mask 0. Oh my god. I want to align everything appropriately. And there we go. So what's going to be the mask mask 1 though? So I suppose, considering what we have here, this is going to be just that, and this is the mask 1. Right. So this is the mask 1. So spelling these things out was actually a pretty cool idea, because I'm now able to see what is going on at least, which is just kind of cool. Right. So, and here we have just 6 of them, so that means I can do 1, 6, minus 1, and yeah, I have to do it like that, unfortunately. And I don't have to do anything here anymore, right? So in the second byte is essentially Emacs is drunk. This is because I forgot a semicolon. That's why it's drunk. So, and here we have 2 bytes. Okay, int 8. So essentially what we do, we take a code point, we apply mask 1. In case of a mask 1, we don't have to move anything because mask is already moved enough. And then we merge it with extend, like this. And I wish something was a little bit better with Emacs, but Emacs worked at this particular point somehow. Right, and finally it decided to recolor everything. Right, and this is the second byte, everything else has to be 0. What are those white dots? It's Emacs being shit. So that's basically what it is. There's nothing I can do about it, I'm sorry. There's nothing I can do about that. Might as well actually put this thing here. Look. Yeah. So this is the format, and this is actually 1 byte format. Alright, I think I extracted everything correctly. If you think about it, what do you guys think? I think it's good. One of those in my Emacs. It's called white space mode. White space mode. So this is how we do that. Try to enable that. Alright, 3 bytes format. Alright, so and we're gonna start with the header yet again. I'm gonna have a lot of duplication. I mean, comparable, tell me about that. Thank you. So uint32 header. So the header, what the header has to be? The header has to be this thing, but instead of these things, we're gonna have zeros. There we go. So this is the header. How we can construct that? So it's essentially 3 minus 1, right? Minus 1, and then we have to move that how many times? 5 times, right? So this is the 5 timer. So moving 5 times. There we go. So this is the header. Extend is the same. Again, I'm repeating the values because I'm not sure how I can compress this code yet. So I'm not sure about the compression of the code. We'll see how the compression will go. So mask 1 is a little bit more sophisticated, because we have to make this mask like this, which is a pretty fucking complicated mask if you ask me. I'm gonna show you why. So here it is. So everything here specifically becomes 0. So I can query replace x with 0, it's already there. And then I want to replace every 1 with 0 as well. There we go. So here we can replace every 1 with 0 as well. Doesn't matter, right? Doesn't matter. But here we have to replace every x with 1. Well, I replaced it with exclamation marks for some reason. Let me try to do that one more time. Exclamation mark to 1. So this is the mask I need. Not the mask I deserve, but the mask I need. There we go. So you see what I'm doing here, right? You see what I'm doing. So essentially, how can you construct such a mask? You int utin32 mask 0. So we have 4 things here. So that means you're gonna do something like this. 4. Yeah. 4 minus 1, and you have 4 of them. And now you have to shift all of that. But how many bytes you have to shift? That's a good question. And this is not correct, by the way. This is not correct. I should have actually removed these things. Yeah. I have to start over. Well, I mean, almost over. I have to start over with this thing. Yeah. So here, let's actually go to 0, 1, another 0, 1, and every x here should become 0. There we go. And we need to get rid of the tens. So this is the size of this thing. One more time. I remove tens, and every x becomes 0. There we go, yes. Then every x here becomes 1. I can probably use this. And there it goes. This is the mask I need. Okay, that makes more sense. I wonder if it's gonna work ever. Alright. So, how do I have to shift it? How many? Okay, 12. Which makes sense. Which makes sense. Alright. So I generated this mask thingy. Cool. Mask 1. So mask 1 is gonna be... I don't know why I go there, because I can literally copy paste it from here. So mask 1 should extract this value. So that means we don't care about this part. We don't care about this part. Here we change this to 0. Remove that 10, and we change this. We change usual thing to 1. So this is another mask. So so that means we have to have 6 here, and we have to shift them by 6 as well. All right. Makes sense? Makes sense. Okay, this is the second mask. You see what I'm doing here? You see what I'm trying to do here? So as far as I can tell, the third mask is gonna be just this. Yeah, it's gonna be just this. And this should be as simple as this. Create a macro for this. I haven't finished yet for making it more concise. You're probably not familiar with my workflow. I actually write like a lot of duplicating redundant code. Like shit ton of it. I just straight up copy paste shit ton of stuff. And the reason why I do that is because I want to identify what exactly is the code pattern so I can compress it properly. So because to create a macro, I need to understand what I'm creating the macro for. What is it going to compress? How much code is going to reduce? What kind of pattern it will represent? And if I don't know that pattern, I cannot create such macro. Like, you cannot start refactoring your code before you wrote shit ton of duplicates because you don't know what to refactor. You're wasting your time. So, okay, I'm writing just duplicates, and then it's gonna be more obvious how to make it better, how to compress it, how to improve it, and so on and so forth. So people who are jumping right into writing a lot of like abstractions and macros, they're usually not really that experienced because, yeah, they never had to deal with complex systems that force you to write code in a style that I just described. Right. First, you gather information, then you implement the code. Way of copy pasting code is a way of gathering information because you're trying to identify what's the pattern in the code that you're trying to reduce. It's quite important. Okay. So now give HR result 3. So how are we gonna do the first mask? So we do code and mask 0, right? Code and mask 0, but that will give us this huge number, which we'll have to bring back 12 characters, okay? So 12, and then we'll have to combine all of that with the header, right? With the header, and then we're gonna do uint 8t. There we go. Here's your first byte, boys and girls. Here's your first byte. How about that? That's why I also don't want to go. Yeah, because you literally don't have enough information to name a thing, right? Because the thing has not emerged yet out of the out of your code. Once it emerged enough, once it has more properties, right, you may try to come up with a name for it. But yeah, it's actually true. I do agree with you. People jump into implementing abstractions without gathering enough information quite often. It's kind of sad. But it is what it is. Holy shit! What are you writing? You just answered your own question. Read your first 2 words. So sorry. Anyway, so we do that, but that means we'll get this thingy here, and we'll have to bring it back 6 bits. There we go, and then we'll have to combine it with an extend, right? And then we want to, wait. So this is that, and this is redundant for sure. This is redundant for sure. Okay, so this is the second byte. We extracted the second byte. Doesn't C++ have binary literals? I think it's an extension. Binary literals. I think it's an extension. Yeah, it's an extension. In C++, you're able to use this feature is already implemented in the latest. Wait, really? Okay, in C it is an extension. Wait a second. All right. Okay, I know that in C it's an extension, but then it never occurred to me that maybe in C++ it is not an extension. Wait a fucking second. All right. So that's finally chat is saying something useful for the first time. Okay, so yeah, let's actually wrap everything up. Cool. Let's try to compile that and go through the compilation errors just to verify everything. Does not name a type. Yes, utin. Utin. Another utin. Another utin. Okay, unused variable, unused variable, unused variable. Okay, where's the errors? Should probably scroll down. Okay, so there's no errors. Cool, cool, cool. So I do remember that I have pedantic in my flags. Pedantic. I don't have pedantic in my flags. Interesting. Okay. Main CPP. Alright, so this is going to be something like std.io. Okay. And we're gonna do something like maybe also std int. No. Oh, we're programming in C++. I'm sorry. Yeah. There you go. Here's your C++. So and b yeah. Okay, and I'm gonna try to compile that with the g++ std c++ 17 pedantic main cp. Okay, who suggested literals? By like literals. All right. There we go. Thank you so much. Thank you. Somebody actually watching what I'm doing, analyzing what I'm doing, realizing what kind of problems I have, and gives the suggestion that is relevant to what I'm doing. This is so rare in the chat. Thank you so much. We need more people like you in the chat. This is so rare. Majority of people just don't want to even know what you're doing. They just want to, show the size of their PP. That's the only thing they care about. They don't care about your problems. They don't care what actual problems you have in the program. No, they just want to show their PP. But that's okay. That's the nature of human beings. We all like to show our PPs, am I right? So, now, let's continue. So that means I can just directly write these things without all of this bullshit, which is actually quite amazing. Tsoding, you can trust me. I trust you. Anyways. Can't show my micro PP. Well, we are on Twitch, so what can I say? We are on Twitch, so we have to be super careful on Twitch with your PP. All right. I have an old compiler for C++20. I'm sorry. I have a boomer compiler, so there's nothing I can do about that. I mean, I could have just done something like this. Yeah. Look at that beauty. Look at that beauty. Isn't that fucking beautiful? Isn't that fucking beautiful? I think it's kind of cool. I like that. Look at that shit. So I think it's C++ 14. It's C++ 14. It's not 17. 14. It's even older than I thought. It's 6 years old, apparently. All right. Beautiful code, exactly. Did I do it correctly? I think I did that correctly. All right. So the B00000. There we go. So, and I want to keep it like aligned and everything. So B000, so we can see everything what's going on. I want to learn, but no idea where to start. Same. Seriously. I want to learn how to handle UTF-8, not UTF-8, Unicode graphems, and I looked into their specification and I have no idea where to start. Apparently you have to read everything. You have to read everything. It's just like, even after like 15 years of software development, that doesn't fucking change. So you basically have to sort of get used to that. So just have to get used to that. Don't worry about it. It's the same for everyone. You don't have mask too. Don't tell anyone. Alright. I complain about that too, but then I look at how much documentation I write myself and see where the problem comes from. Well, I solved that problem. I don't write documentation. So I can complain of other people's documentation. Anyways, so yeah, we need this thing. So here's a mask 0, and we do that, and similarly, we're gonna have mask 2, which does not require any shiftage. I still wanna kinda shift it because it creates like a pattern that is obvious, right? So... But Zozin, this does not have any effect! Zozin, this does not have any effect! This condition is always true! Zozin, don't you see that? Don't you see that? Oh my god, why are you writing that? Well, maybe there is a reason why I'm writing that. Anyways. Let's go for the 4 bytes. Wasting CPU cycles. I mean, the compiler is gonna remove that anyway, right? The compiler is gonna remove that anyway, so the only CPU cycles I'm wasting is the CPU cycles of my machine, but not the user's machine, right? Not the user's machine. So compilers these days are kind of smart, so I think we can actually sacrifice a little bit of, you know... I don't even know what we're sacrificing by writing this, like space on a hard drive? Like, what are we sacrificing here? Like, we're sacrificing something for a little bit of readability, for like being able to see the pattern, right? So, like, anyways, indent, please. Oh yeah, I see. I'm sorry. Just a second. I can do it like that. There we go. Emacs, could you please stop? I don't even know what the fuck Emacs is doing. Okay, so everything is code golf these days. Don't you see? Oh yeah, apparently yeah. So if you don't golf your source code, well, you're not a real programmer apparently. Yeah. Fuck seeing the patterns. Your code has to be like compressed with gzip. Yeah, by the way, here's an idea. Let's actually add support for GCC to like work with gzipped files, and let's just compress our code with gzip. So this way we don't have to think about that. All right. Now, so this is gonna be the header. The header that I want to have is going to be. Yeah, I'm really apologize for Emacs. It's so Pepega. Okay, I just removed like white space mode. It became a little bit better. So header is 11110000, and there we go. So here's the header. And extend is pretty much the same, right? Extend pretty much the same. Extend. I press the control V and non-read close my tab again. Classic. Fucking classic. I especially, by the way, I especially like the web-based terminals with readline utilities in them. You see where I'm going with that, right? So you type something there, thinking your brain thinking that this is a bash, and as you would do in the bash, you can press Ctrl W, and that closes your fucking tab. Because a lot of such pages, they don't handle Ctrl W. Cool. Anyways, so mask 0. Mask 0, and essentially what I want to extract here, I just want to do, I'm going to show you some cool trick. I think I want to query replace 10 with nothing, boom, then I'm going to query replace x with 0, like this, and then I'm going to merge all of that, and I'm going to query replace x with 1, boom, and there we go. And then look at that, legitness. Isn't that fucking epic? Isn't that fucking epic? I think it's pretty fucking epic, mate. Next one. So the next one, the byte 1, has to be something like this. So I have to query replace 1 like this. Then x with 0, and then connect them. And then I'm gonna query replace x with this and like this. And then I actually shouldn't use spaces. I should have used zeros. Too many zeros. There we go. So we can clearly see how we just, you know, take different stages and stuff like that. So mask 2, the next mask, is gonna be like this. I'm gonna remove that. Query replace that with 0. Query replace that with 1. Then like this, and then a line. There we go. So you see how it goes like from left to right and picks like each individual bytes and stuff. This is so painful. This is not that painful. I don't think it's more painful than working with Unicode graphemes. Anyways, so, and the last one is going to be essentially 6 of these, right? And yeah, there we go. So there we go. So we have different sections of the integer to extract. So to be fair, like binary string literals, they really help in this kind of situation, because at least I can finally see what the fuck is going on in a bit mask. So yeah, so that's actually pretty useful, not gonna lie. So this is 0, this is also 2, 1. Okay, cool. So to be fair, I'm not even sure if I want to extract this or compress that or anything like that. I kind of like how like obvious everything is, so might as well actually keep this code like that. So I really like it. I like the readability of this thing. I like the readability. So we're gonna have 4 bytes here, and we have a code. We apply a mask 0 to it, and now we'll have to shift it to the right. Right, we'll have to shift it to the right, and 18 characters. By the way, did I ever do everything correctly? Right, 18 characters. 18. And then I'll have to come out with the header. You can also use to visually split binary. That's not a bad idea, actually. Let me try. So this is the first one. 1, 2, 3, 4, 5, 6, 7, 8. So is this 8? This is 8. This is not a bad idea. Yeah, this is 8. Okay. To be fair, like here, it doesn't really help much. Right, here it doesn't really help much. But at least here, it kind of helps. I don't think. This is, yeah. Because this mask, like, they go across the bytes, so they're not that particularly useful. Okay, so then we compile it with the header, and we are ready to do this kind of thing. Hello, Luke Gorilla, welcome to the stream. Alright, so the next one, code mask1, and how we have to move it. So this is mask 1, and 12 characters. As you can see, there's like emerging pattern here. Alright, so it's that, then extend. And then this is the second byte. Alright. Next one, code mask 2. We'll have to do like 6. 6. Extend u int 8t. There we go. And we also want to line this thing. And the last one is going to be just code mask 3 0. But Susan, no, you don't have to do that. Alright. So u int 8t. Cool. Wonder if it will work first try. It's kind of interesting. What do you guys think? Is it gonna work first try? Is it gonna even compile? That's a good question. But that shit is kind of scary. Pause jump. Oh, I'm not even compiling it properly. Make minus beam. Come on. It complains about some stuff. Aha. Yes. Thank you. It complained about unused variable. Thank you so much. Oh shit. That is so cool. I forgot about returning some of these things, like in this particular place. Redundant code. What? Who are you calling a redundant code? You are redundant code. Right, is it compiling? Oh, wait. I should have actually compiled what is the bug. Compiler cares about clean code. I mean, there was a bug in there, straight up. Alright, seems to be working. It seems to be working. Alright. So now... yeah, now we have a function that is capable of, you know, taking Unicode code points and just turning them into like a UTF string. Isn't that fucking amazing? Let's actually test how it works. Crying with joy emoji. Let's find its Unicode code point. Where is the code point? Does anybody know the code point? Oh, here it is. So I'm gonna just take that, and I'm gonna do something like this. This is main, and here it is. So the code is gonna be this code that, and here is an interesting part. Oh, I didn't think about that. We should probably implement like a printer for UTF-char. I think that would be cool. Essentially, you'll be able to print it like a string or something. Print, so it's gonna accept file stream. And strema, not strema, but this. uchar. And how we're gonna print all of that? I think the easiest way to print all of that is to actually do print stream. And construct a string view out of that. All right, in string view, the first thing is a count, char count. Hello, Limpid Xonix. Thank you so much for saying hi to me. Because people rarely say hi to me. I'm joking, yeah. I'm very interested in how you earn a living. It's kind of strange because I'm not interested in how you earn a living. Like, why would you be interested in my way of earning a living, right? Maybe we all should mind our own business, you know? I don't care how you earn your money, you don't care about how I do. You know, a little bit of self-respect around here. No? Okay. So, not self-respect, I think I used the wrong word, but I don't speak English anyway. Okay, so it's bytes actually. Sorry. Oh, don't be sorry about that. Don't be sorry. Oh shit. Can I just, you know, cast this thing? Can I just cast it to something like static cast unsigned char. Actually, just a const char. Can I do that? Is that like something I can do statically? I think I should be able to do that statically. No? No? Invalid static cast from... okay. Can I just reinterpret cast that? Then just let me do that. Anyways, so how do we even do that? Code to UTF, and we'll provide code, and after that we should be able to print that to std out, like this. And might as well actually inline the code. Is why node. So it should be as easy as that. So you get the like UTF-8 char, and yep. I resented the chat. Yep. Cheers, by the way. I wish I studied CS instead of physics. I just can't send a mail for a PhD opportunity which pays 70k and fair. I don't think it's that difficult to learn CS on your own. And as far as I know, in modern physics there's a lot of CS anyway, because modern physics is pretty much programming anyway. Right, because you have to deal with a lot of data, and like dealing with a lot of data is a lot of algorithm and a lot of CS problems. So I don't know, but I'm not a physicist, so I don't really know what are the daily struggles of physicists. Anyway, so here's the thing. You're a physicist, right? So yeah. Seems to be compiling, and let's see if it will actually print the crying emoji thingy. So the crying emoji thingy, I'm gonna execute it like this, and it actually did. Look at that. Look at that. We provided it like a code point, and it managed to take that code point and encode it into UTF-8. First try, by the way. How about that? Who's got cooler now? Yo, Anaboth. Hello, welcome to the stream. Welcome to the stream, Anabuthu. Anabuthu-sama. So, what other emoji we have to use? Poop emoji? Let's try poop emoji. Poo? Pile of poo. Okay. The most weirdest and quirkiest emote out there. Anyway, so where's the thing? So it's gonna be like this. Code to UTF-8. Okay. Println, std out. I'm not gonna actually remove that. So I'm going to make this back. This we go. It didn't fucking work. Okay, because I was in the wrong folder. I'm gonna do the thing. Please print the poop emoji. Yes, it printed something, but my Emacs is incapable of actually displaying that, so I'm gonna copy paste it into the. And there you go. Here's the poop emoji. Poop emoji. Yeah. So I think it works, but as far as I know, also poop emoji is 4 bytes. I think we need to test all of the situations there, and we need to test all of the situations, like 3 bytes, 2 bytes, and a single byte. That's for sure. So let's do something like check summary code. So you provide the code here, right? And we do uchar code to UTF-8. You provide the code, right? And what we're gonna print here is essentially. Do I have hex actually in AIDS? I don't, but I might as well actually implement it at some point. Anyway, code looks like uchar size. Okay, code. Display. I don't know if it's a good name for this. Char. Code display size. char size. So this is basically what I want to be able to do. And we're gonna have something like this. Summary code. Doesn't compile, by the way. Where did I do fucky wacky? Count. Okay. So as you can see, their size is 4, which makes sense. So as far as I know, for 3 bytes are usually Japanese symbols. Can anyone type something Japanese in the chat? Like, you know, katakana or hiragana, I don't know how they're called, but I know that they are usually like 3 bytes and stuff. Thank you so much, Anabotho. I'm gonna take this symbol because it looks like lambda. Right, it's a lambda. And can I actually find its code in there? Okay, so let's try to Google that. Code. Okay, 3093. All right, 3093. It's lambda. Come on. It works, and it's size 3. So let's actually now use some Russian symbols. Let's use reversed R. It's 042F. All right. 04 to F. Looks cool. Okay, so was it capital 1? Oh yeah, it was a capital 1. Okay. All right, and now we can take a look at ASCII. And let's take a look at something. Let's find E. So in hex it's 45. It's 45. All right. So it's going to be something like 45. There we go. Oh, Domson, hello. I haven't seen you in a while. How are you doing? Look at that. Look at that legitness. We managed to convert. Oh, whoa, would you look at that? 69. Did you know that the ASCII code in decimal of letter E, capital letter E, is 69? Isn't that nice? I think it's pretty nice. I do think it's pretty nice. Anyways, so we have like an actually working mechanism that can take code point and turn it into UTF-8. So we can actually take like a whole string of code points and then encode it into UTF-8 by iterating over them and just calling this function and whatnot. So, and that's actually a pretty cool mechanism. I'm really proud of it. Jiang, oh my god, you know what we just implemented? Do you remember how we had like a code to UTF-8? I mean, yeah, so basically you can take UTF-8 and take code out of it. We implemented an opposite thing. Now you can provide the code and it will return you like UTF-8. Yeah. Doing, how's Tsoding doing? Looks like a new apartment. Yeah, I had to move. So I'm in a new apartment now. Got Kudur, and I actually got reminded that binary literals are a standard thing in C++. I didn't use them because I remembered since the C time that they're extension, but they're extension in C, but they're not extension in C++. So I can use them, and I use them to, you know, compose the masks, like do a bit more visually. So price B2 Strauss-Trupp. Did he push that idea to C++? It's actually pretty convenient. What do you do in your pastime if not coding? Let me think. I cry. And also eat. Actually don't do anything. Seriously. Because this activity is so draining. Which after the streams, I don't really have much like power to do anything. I'm sorry. So yeah. Anyways. And this is the feature. That is going to be. Crying adds necessary salt to food. Yes, exactly. But that salt goes back to you. So you're spending salt to salt the food, and that salt goes back. Streaming is hard job. Nah, not really. Because it's not a job. It's hard, but it's not a job. So technically, it cannot be a hard job because it's not a job. See? Now, that's close enough, I guess. But imagine explaining to anyone what you're doing for a living. So maybe we should return maybe UTF char, especially in the situations when it's like out of the range. But I'm not sure. Are you going to Japan? I wish I went to Japan, but I don't think I have enough money to go to Japan. Actually, I don't know. Whatever. Just walk there. Oh, I see. Whatever. I probably won't be able to ever get out of this shithole, so I don't really care. So now, why I was doing all of that? So it's actually quite important why I was doing all of this. So we need to first release the next aids. It's going to be something like 0230 code to UTF-8 So this is what we introduce here. We introduce this function, and also we introduce UTF-8 char. So we introduce like a struct UTF-8 char. All right, and also we have to update this thing. And we are about to release the new version of AIDS. So it's actually located here somewhere. So if you come before my visa runs out in April, then I can sleep. You can sleep in my floor, Mr. Tsoding. I probably won't be able to go anywhere. Thank you for the suggestion, but yeah. I also, it's not only financial problems. It's all sorts of things. Ivanhoe, thank you for 10 bits. Thank you so much. So yeah, AIDS release, yes. So I forgot the name of the project I'm working on. All right, new AIDS release, yes. 3 release. Code to UTF-8 struct UTF-8 char. All right. Wait. Did I not commit that? Oh, okay. I think I'm going crazy. I'm sorry. So I'm gonna push that right into the repo, and the new version of AIDS has been officially released. So yeah, now we have a new version of AIDS. Isn't that epic? Isn't that epic? I think it's pretty goddamn epic. So, and one of the things I want to do here is probably commit the new version of AIDS, but then have the separate branch that I'm working on. So it's going to be Unicode emojis, and it's going to be 133. There we go. And this is what we're going to do here. Upgrade AIDS 220, 230. Let's push that into the room. Nice one, Jay. Nice one. Classic. what I need to do now, essentially for new people who just joined, because we were working on this feature for quite some time, we don't really remember why I'm doing all of that. So we have this emoji pack, right? We have this emoji pack from Twitter, and essentially what it has is a bunch of files, and each name of the file is actually the Unicode graphem, right? So, and the reason why we need to take a code and turn it into UTF-8 is because we're parsing their name and turning them into UTF-8 characters and then concatenating them together, and that will give us UTF-8 graphem that we can use as the name of the emote while rendering it. You see, that's the reason why we do that. So we use the file names to build the emote mapping, sort of speak. So that's essentially what we're doing. We'll see how it goes. We'll see how it goes. Cool. Where is the... So I need to revert this thing. So once we have that, and all of that is part of the standard library, we can start using this kind of stuff. So we have emoji path as UTF-8 string. And I suppose I'm going to use dynamic array to actually represent that string. So it's going to be dynamic array. So it's a char. Let's call it result. Okay. So we're extracting the new character from the graphem. New character from the graphem. UTF-8 char. What is going on? Is everything... So we can render B in Vodus. Yes, we should be able to render B in Vodus at some point. So this is going to be uchar. Where's my 8s? Code to UTF-8. So we have a code. So essentially, this is like a chain of things we're doing. We're taking the file path, we parsing that file path, extracting these code points, we converting them to like a U32 code point, then we turning it into UTF-8, and then we can concatenating them together. This is actually pretty goddamn sophisticated operation, and I'm doing all of that in C++ with purely homemade solutions, right? I have my custom like parsers of strings. I have my custom conversion from hex to decimal. I also wrote it myself. I also wrote myself conversion from code point to UTF-8. I like did this entire operation completely from scratch. So I could have actually implemented that completely in assembly without libc, and that would work as well. Jesus fucking Christ, why do I do that to myself? Anyways, so the only thing that I didn't master is how to parse graphems, but apparently it's extremely difficult task, and there's like no simple rules to that. Like the only thing I want to know how to determine the boundaries of graphems. So it's probably like the rules seem to be sophisticated. Okay, so we're converting this thing there, and I can do the following thing. I can actually concat the result like this. So uchar data, uchar count. Right. So, and the result might as well actually return no uchar. Okay, I might as well actually pass the dynamic array like this, right? Does dynamic array struct dynamic have a clean? It doesn't have clean, so you have to clean it yourself. All right. So essentially, you have to take its size, right? And then we're concatenating it. Like this. And that. So I also need something like this. Dynamic array char name. String as viewed, so we parse it, and we also provide, okay, so this thing has to be 0 initialized. This is quite important. This is quite important. And then we provide name here, and then we're gonna do the following thing. So we're gonna take the name data, and then we're gonna print the path that corresponds to this. All right, so I think I finished implementing the name parsing of the emoji pack. I think I managed to implement that. All right, so let's try to run this, and it's bytes. Yes, I think it's bytes. And invalid conversion. Okay, reinterpret cost. Char. Like this. We'll have to do that, chat. We'll have to do that. So there's no thing here, and we're almost there. We're almost there. So warning control reaches. Yeah, I know. I might as well actually return this thing. But that's gonna be another. Oh, would you fucking look at that? That shit is kind of scary. Something is wrong here, by the way. Something is definitely wrong. Because this is like a single byte, but this is how much it returned. It doesn't make sense. I think I did a fucky-wacky somewhere quite severely. Specifically in counts. Maybe in dynamic array. So let's go to aids. Struct dynamic array. When I do concat, first is items and second is item count. Okay, that makes sense. UTF-8 char. Did I provide? So this is 1, this is 2, this is 3, this is 4. All right. So and also maybe it makes sense to put it like that. It's kind of strange, right? So and also I need to print the full path. I need to print the full path. The full path is going to be base path, like this. So, and we'll see how it goes. At least we're going somewhere, which is kind of cool. That's a lot of actually files, look at that. Maybe without this thing. So, let's actually redirect all of that to our txt. So maybe it's going to be a little bit faster, hopefully. Okay, and let's open out txt. Okay. Oh, I see what's going on. I forgot null terminator. Fucking classic. Fucking classic. You know what? Yeah. So it has to be result push. Yeah, it has to be like this. It should be a little bit faster now. So that was the actual problem here. And now it makes a little bit more sense. So this is some sort of like a feast, and if we take a look at it in a file, it is in fact feast. So we actually, you know, managed to convert a file name into an actual like emoji in a sequence of UTF-8. So, and here it is. So this is some sort of a cross. Not everything Emacs is capable of showing, but this is a cross, obviously. So we can take a look at these graphemes. All right, so if we copy paste this grapheme into Chatirina, it does work, but Chatirina also doesn't really show it properly. Kind of, it shows it partially. So, but overall, it does work. So we literally extract this sequence of bytes from the name of the file. Jesus. This is a big one. This is a really big one. And by the way, essentially, we can already write it in a mapping format. So we have emote mapping, right? It's just a CSV file. So we might as well actually like just make it a CSV file. Why not? Just make it a CSV file. Just make it a CSV file. And so you should be able to use that in the rendering and stuff. I wonder how it's gonna go. All right, so yeah, this is basically CSV. And I might as well do a very pro gamer move and append all of that additional information to our mapping CSV. So it's going to become part of the mapping CSV. Okay. Yes. So in the mapping, yeah, we have Twitch emojis, and then we have like Unicode emojis, and then we're going to go to the sample. Right. We're going to go to the sample, and somewhere here, we can make plot spam crying emoji. Okay, joy crying. So then I'm gonna copy paste this thing like this, and what I want to replace this thing with is PHP hop with this. There we go. And let's see how it's gonna actually render all of that. I think it's kind of interesting. So where's the main? So this is going to be main 2. This is going to be just a regular main. And let's try to compile all of this. Debugus. Seems good, seems good. Alright, and now I'm going to try to render this entire thing. Let's see how it's going to go. Oh, it's loading emojis. It's loading all of them in the memory because it cannot... Oh shit, is it really? Oh shit. That's really strange. Is it doing anything? It's actually doing something, but I'm not sure what exactly it's doing. The emoji loading, as far as I know, is actually... lazy, so it shouldn't start like loading and resizing, and it doesn't even consume that much memory. It doesn't consume that much memory, so I don't really know what it's doing. It just has 100% of CPU. No, the problem is not the memory. I don't know what it's doing. I don't know where it's stuck. It's stuck somewhere. So we can try to kill it. And try to troubleshoot that and see where exactly it's failing. So it's definitely like failing on populate from file. Let's take a look at that. Let's take a look at that function, populate that file. So you read this entire thing into the memory. Is it a big file? Is it really a big file? Mapping CSV. Like it's 200 kilobytes. It shouldn't be that difficult to read into the memory. Come on. Right. Then we should just be able to add all of that. Thrashing? I don't know. Okay, let's see where exactly it fails. Maybe we can try to GDB that. So let's GDB Vodus Debugus. Are you guys ready for debugger wagga? Use an AI to generate text. Yes, that's what this. It's an AI to generate text. Oh, God damn it. Oh, you can actually. Oh shit, that's very interesting. You can do Control C and it will stop at a particular point. Is that? Okay, you caught my curiosity, actually. I didn't know that GDB can do that. So in GDB, you can press Ctrl C and it will, you know, send sig int at that particular point and actually break there. That's cool, I think. That's pretty cool. I didn't know they can do that. So let's break main. All right. So let's go to enable, and let's see where exactly, on which step it starts to, you know, fail. Okay. So everything is actually loading pretty fast, not gonna lie. Of course, it's printing some stuff that ruins GDB. Okay. It populated the emote cache. Okay. Okay, so the population of the emotes is not that big of a problem, apparently. Emote mapping capacity. So how many emotes we can fit there? Actually thousands, I don't think. How many emotes do we have in the mapping? So -cell mapping CSV. Oh, I see. And why didn't we have any? Okay. All right, that's kind of strange, but okay. Let's have like, I don't know, 5,000. It's kind of dumb, I know that, but it is what it is. What is debuggers? Okay, cool. Is it gonna fail now? Okay, it works now. I just had to increase the size of the hash table. Okay, that was dumb. I need a normal hash table. Jesus Christ. I have so many embarrassing shit here, but anyway. There you go. Does anybody have any suggestions for the emotes that we can try to render? Does anybody have anything? B. Okay. So 4. It's actually going to be 3. This is going to be 6, and no, it has. This is not a part of the Unicode emoji. I'm sorry. So it has to be part of the Unicode emoji. So unfortunately, the consequence of this entire thing is that you have to put spaces between the emojis, which is like a little bit of an annoyance. But to fix that, we have to understand how to get the graphems things. I think this would also be rendered properly, but this is not an emoji. But we can put that there. Yeah, there you go. Interesting. So technically it is possible to have emojis. Maybe this. It's kind of funny that even Chaterina cannot understand this graphem at all. Right. So because this is obviously a graphem, right? And let me take a look. It even... So this is a question mark, so let's try to remove spaces from here. So I suppose this is the graphem. If I take my mapping, can I find this graphem there? I cannot find it actually. Can I find like first two? I can, and what is it? Okay, it's a Japanese flag. Okay, what's the second one? Huh. Okay, makes sense. But there's no these two things together. But I mean, we can test if the... Okay, so this actually makes sense. Alright, I see what you... for some reason I thought it's a single graphem. Yeah, I don't know why my brain thought it's a single graphem, but for them to work I think I have to split them like this. Alright, let's try to render that now. I didn't re-render. Goddamn. Just a second. I'm sorry. I'm already a little bit tired, so that's probably why. Okay. Surrender. What is drawing the emojis? My program is drawing the emojis. I'm not sure what you mean. What do you mean? My program draws them. Okay, it works. Seems to be working. We don't have a question mark in the mappings, but the font seems to be supporting this white question mark. Yeah, so as you can see, we even support graphemes, but only if we know the boundaries of the grapheme, right? So only if we know the boundaries. And unfortunately, if the emotes are stacked together, we can't really know the boundaries of those graphemes. There is an interesting trick I'm thinking about. Maybe we can build some sort of like a prefix tree or something and just go the other way around, like find all of the emotes in the message, and that way you can find the boundaries of that grapheme, so without implementing any weird algorithm stuff like that. Can you teach me how to make a text editor like Vim? I want to make a terminal text editor of my own. But why? If you can just use Vim, just use Vim. And that's it. Don't worry about it. Don't worry about it. So technically this entire idea works, right? So, but I don't really understand how to implement it in practice, right? Because like, how are you supposed to get these emojis? Yeah, so basically, instead of, like, we already know all of the possible graphemes we need. Do we really need to implement this weird, like, Unicode algorithm of finding the boundaries of them? Do we really need to? Because we already know all of them. Might as well just find them in the text. So dumb, but at the same time, like, yeah, you just don't have to do that. I don't know, I'm thinking about that. But the main problem is, like, you have a program, and how do you get that emote pack, and how do you set it up, right? And how do you create mappings and stuff like that? Well, I'd rather solve a data structure problem than solve a Unicode problem. Yeah, me too. I looked into Unicode at the beginning of the stream, and I was so frustrated. You would see in the VOD if you watch VODs. I don't know if you watch VODs, but yeah. So yeah, I still don't really know how we're gonna do that, because we have an emote downloader. That emote downloader can also try to download. Oh yeah, that's a pretty cool idea. We can make emote downloader download Twitter emotes for you and set up everything for you. Yeah, okay, so this should be like the responsibility of the emote downloader, I think. So because right now what we did, we just downloaded the Twitter emotes and we set it up ourselves. But yeah. So so where's the emote downloader? Emote downloader. Okay, so I'm gonna put a couple of to-dos here. Do emote downloader should download and set up the Twitter emoji pack. All right, so where is the original? So I had like I created this weird thing here. All right, so Twitter emoji pack. So here it is, and here is it is in the chat if anyone is interested. Thank you, Freefool, for pointing it out. So this is the first thing that we're gonna have here. The second thing is there's something wrong with the emote CPP here. emote cache. So this is what I'm trying to do here. Emote cache populate from file should crash if we don't have enough emote capacity, right? So because we need some sort of an indication of what's going on, and I suppose that's pretty much it. Yeah, do I want to like? Yeah, I think I'm gonna remove all of these algorithms because I'll have to re-implement them anyway at some point. So here are emotes, this, aids. I'm not gonna add that to aids. So we're gonna have that stuff. Remove that. Yep. I'm gonna remove that as well. Just cleaning everything up. Just cleaning everything up, and yep. Okay. Additional work. There's also interesting thing. Yeah, I suppose I'm not gonna just close the issue. When the emojis are displayed, is that the default console stdout or is it something else that renders them? I look at the Git, didn't see the external library for console unless I missed it. This is a video. I'm literally opening a video. The program generates a video. This is not the program running. We're watching a video generated by our program. Yes. All right, so let's create the pull request. Let's quickly create the pull request. Small research towards emoji support. It's so strange how you pronounce video. I love it. I'm supposed to pronounce like video? And that's how I'm supposed to pronounce it? Sorry, I don't speak English. Video. It's a Slavic word. All right, video. Yes. Okay, so I need to snitch it up. Do you do full-time streaming or just fun quarantine time pass? Well, I stream for 4 hours, which is already part-time by the definition. Depend volume introduced 155. All right. Okay, today was more or less interesting stream. Not sure if it was productive because I had to deal with the two most cancerous things in the software industry. It's libav format and Unicode. So, but we did something. At least we found that maybe we have a workaround, so we don't have to deal with all of that shit, which is kind of cool. So yeah, but unfortunately, boys and girls, it is time for me to go. Thanks everyone who's watching me now. I really appreciate that. Have a good one, and I see you. Actually, I'm gonna see you all on Friday because tomorrow is the day off. But on a Friday we're gonna have a random one-off topic. So that means I'm gonna pick a random topic and stream it for the whole day. Also check out our schedule for more information on different streams, different projects we're working on. Check out our WOTS channel where we archive the streams, right? This stream isn't going to be there, but tomorrow, right? So we usually upload the WOTS the next day. And also check out our Discord server for offline discussion with the community. That's pretty much it. So thanks everyone for watching, and I see you all on Friday. Love you. Mwah.